Okay, so carrying on where we left off with I to the negative 29. So anytime we see an exponent with a negative, all that really means is that it's like 1 over I to the 29. So that's kind of one way that we can start these questions. So I to the 29, if we take 29 and we divide it by 4, see what we get. We get 7.25. And importantly, we get this remainder here of 0.25, which means that I to the 29 is just going to be equal to I. So basically what we have now is that I to the negative 29 equals 1 over I. But we can go a little bit further here. And if we just focus on 1 over I, if we take this and we multiply it by I over I, which is the same thing as 1, we get, or well, it cancels each other out. So we get I over I squared. So I squared is just negative 1. So we get I over negative 1, which is just negative I. So that's the way I like to approach these problems, is start by just getting them in the denominator, and then remembering that once you've figured this part out to here, if you multiply by I over I, you can, or whatever, if you have I cubed, it might be a little bit different, but you can multiply it and kind of rewrite it here. So that's how I like to approach these ones. So looking at this last one, D here, we have I to the 46. So 46 divided by 4 is going to be 11.5. So because we get this 0.5 remainder, that means that we have 2 i's left over, basically. So we're going to have I squared, which is just going to be equal to negative 1. So this one is negative 1, and this one here was negative I. And again, earlier I explained it's just a repeating cycle where you have I to the first is just I to the second is negative 1, I to the third is negative I to the fourth is just positive 1, and then I to the fifth loops back to I. And you just keep going around. So if you're able to divide out an I to the fourth, basically, or factor it out, then you can reduce this way down to something that looks more like this, and then you can go from there. Okay, so now we're going to do some operations using imaginary numbers, and importantly, we need to remember that we have to write this in this standard form here. So for 5 plus 2i plus 6 minus 5i, this one's pretty simple because we just get to combine all our like terms. 6 minus 5i. So 5 plus 6 is 11, and then 2i minus 5i is just going to be negative 3i. So this one here works out to be 11 minus 3i. So this next one, B here, we have the same thing, except for we have to distribute a negative 1 first. So we have 2 minus 6i minus negative 4 plus 6i. So this is the same thing as writing it like this, plus 4i minus 6i, just from distributing that negative. Now we combine like terms. So, sorry, this is just 4 here. So if we combine like terms, we get 6 minus 12i. So that's this one here. Okay, part C, we're going to make things a little bit trickier, but still not too hard. It's the same as what we used to do where we have to FOIL it, except for now we're just including i's. So if we FOIL this out, we have 4 times 5 is 20. 4 times I is 4i. Negative 7i times 5 is negative 35i. And negative 7i times I. So our i's, we're going to have I squared. I squared is just negative 1. So we wind up with plus 7. So all this together, we get 27, and then minus 31i. Okay, then lastly, we're going to divide two complex numbers. So this one's probably the trickiest, but you're always going to have the same approach. So we have 4 plus 3i over 3 minus I. So you want to multiply both the top and the bottom by the conjugate of the denominator. So the conjugate is basically just where you take this middle term here and you make it the opposite sign. So if we multiply by the conjugate in both the numerator and the denominator, we multiply by 3 plus I. Oops. Over 3 plus I. So now it's just like we have to do two of these FOILs. So starting with the top one, we're going to have 12 plus 4i plus 9i, and then 3i times I is I squared, so, or 3i squared, so that's going to be negative 3, over, so we're going to have 3 times 3, which is just 9, 3 times I, so that's going to be plus 3i, negative I times 3, so that's minus 3i, then negative I times a positive I, so we'd have negative I squared, which is just negative 1 or positive 1, so plus 1. So notice this and this will cancel each other out. So we'll be left with, and if we combine like terms, we'll have 9 plus 13i over 10. And then whenever we write that in our standard form, we're going to do 9 over 10 plus 13 over 10i, and that's it. So it's a little tricky, but you just follow these same steps where you multiply the numerator and denominator by the conjugate of the denominator, and then just work on foiling and simplifying. Okay, number 14, solve the quadratic equation by factoring and applying the zero product property. So first thing we do whenever we factor is we make one side 0. So we can do that by adding 9 to both sides. So we end up with x squared minus 10x plus 9 equals 0. So now we need to think of two numbers that multiply to 9 and add to negative 10, which means that there's going to be two negative numbers because this one is positive. So we can factor this, we can make it x minus 9 and x minus 1 equals 0. And then applying the zero product property, really all that means is that if, say for example, we plugged in 1, we know that this part here would be 0. And because anything times 0 is 0, we wouldn't really care what this is. So we're allowed to take this factored form and break it into two separate equations, just like this. So from here we get that x equals 1 and x equals 9. Okay, 15, we're going to solve the quadratic using the square root property. So if we have x plus 1 squared equals 9, square root property, basically we're just going to take the square root of both sides. And whenever we take the square root of something that's squared, like this, we basically just get to cancel it out. So we'll have x plus 1 equals, so this is the tricky part, and it's that whenever we take the square root, we end up getting a plus or minus, because the square root of 9, it could be 3, but negative 3 times negative 3 is also 9. So it's going to be one of the two. So we can write plus or minus 3. So now we just need to subtract 1 from both sides. So we get two separate answers. So we get that x could equal, so the positive version is 3 minus 1, so it's just 2. Or the negative version, negative 3 minus 1, is negative 4. So x equals 2 or negative 4. Okay, so for number 16, we're going to solve by completing the square and applying the square root property. So we have x squared minus 6x, and then plus 11 equals 0. So anytime we complete the square, we want to start by looking at this here, this b, right? So if we take negative 6 and we divide it by 2, we get negative 3. Then we square that and we get 9. So we know that the part that we're going to want to add is 9, basically. So you can either think of it as breaking this 11 into a 9 and 2, or you can just think you're going to add and then subtract 9. So we get that x squared minus 6x plus 9 minus 9 plus 11 equals 0. So we haven't altered the equation. It's still the same because it's just 0. And again, I got 9 from taking this negative 6, dividing it by 2, and then squaring it. So if we go from here, we know x squared minus 6x plus 9 is just going to be x minus 3 squared, and then plus 2 equals 0. So now we just have to solve for x. So we get that x minus 3 squared equals negative 2, or x minus 3 equals plus or minus the square root of negative 2. So whenever you take the square root, you have to have plus or minus there. So we get that x equals 3 plus or minus. So if we have if we have negative 2 inside of our square root, we can just change that to be I square root 2. So that means our answers are x equals 3 plus I square root 2 and x equals 3 minus I square root 2. Okay, so for number 17, we're going to do the same thing. So for now, we have a little trickier question. So we have 2x squared minus 7x plus 12 equals 0. So I'm going to start by dividing everything by 2, just that way my a value, or my coefficient in front of x squared, is 1. So if I divide everything by 2, 7 halves x plus 6 equals 0. So now I'm going to take this 7 halves, divide it by 2, and then square it. So that's going to be 7 fourths squared, which is 49 sixteenths. Which is kind of a gross number, but we can work with it because it's going to be the same process. So we're going to have minus 7 halves x plus 49 over 16 minus 49 over 16 plus 6 equals 0. So now we can factor this first part here to be x minus, and again, it's going to be x minus this number here, the 7 fourths. X minus 7 over 4 squared, and then we're going to have minus 49 over 16 plus 6, so that's the same thing as doing minus 49 over 16 plus, so if we multiply 6 by 16, we wind up with 96 over 16 equals 0. So then we can combine those terms there, and that's going to get us 47. So we get x minus 7 fourths squared plus 47 over 16 equals 0. So now we can move the 47 over 16 to the opposite side. So if we do that, we get x minus 7 fourths squared equals negative 47 over 16. So then we take the square root. So we're going to have x minus 7 fourths equals the square root, and plus or minus, of negative 47 over 16. So we have a negative square root, so we can pull out an I. If we do that, we get x equals 7 fourths plus or minus I square root 47 over 16. And we can technically do a little bit of simplifying here because 16 is a perfect square. We could say that square root 47 over 16 is the same thing as square root 47 over 4 times 4. So we can factor out a 1/4 basically. So if we do that, we get x equals 7 over 4 plus or minus I square root 47 over 4. So if we write our answers here, we have x equals 7/4 plus I times square root 47 divided by 4, and x equals 7/4 minus I times square root 47 over 4. Okay, for 18, we're going to solve this using the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a, where a, b, and c are just the coefficients. So the first thing that we need to do to solve this is move everything to one side and have it be equal to 0. So we have negative 2y squared minus 5y plus 1 equals 0. So I'm also going to multiply this whole thing by negative 1 because I feel like getting rid of some of these negatives might make it a little easier. So this same thing as this. So now we just know a equals 2, b equals 5, and c equals negative 1. So now we just take these and plug them into here to solve for x. So x will equal negative 5, plus or minus the square root of 25 minus 4 times 2 times negative 1. So that's going to be plus 16, or excuse me, plus 8. All over 2a, so that's just 4. So x will equal negative 5/4 plus or minus the square root of 33 over 4. And there's not really any way to simplify square root of 33, so we can leave our answer as this. So x will equal 5/4 plus square root 33 over 4, and x will equal 5/4 minus square root 33 over 4. Okay, so for number 19, we're going to evaluate the discriminant and determine the number and type of solutions to each equation. So if we go back to our quadratic equation just for a second, the discriminant is just this portion here, that b squared minus 4ac. And the reason why that's so important is because it can tell us if we're going to get imaginary answers, if it's less than 0. We can tell if we're going to have just one answer, if it's equal to 0, because then we would have plus or minus 0, or if it's just going to be 2 real answers. And we can do this here. So I'm just going to write that the discriminant, I'm just going to write it as d for now, is equal to b squared minus 4ac. So from here, starting with a, we have a equals 4, b equals negative 20, and c equals 25. So for this one, we have negative 20 squared minus 4 times 25. So this is going to be 400 minus 16 times 25, which is also 400. So this one here is equal to 0. So the discriminant, which we'll call d, equals 0, and determine the number and type of solutions to each equation. So because our discriminant is 0, this plus or minus portion here is going to be 0. So that means that we're only going to have one answer. So one real answer. Okay, now for part B here, it's the same thing. B squared minus 4ac. So b is equal to 7, so we're going to have 7 squared minus 4 times a is 5 times c is negative 20. So we get 49 minus 20 times negative 20, so that's plus 400 is equal to 449. So we got a positive answer that's greater than 0. So our discriminant is equal to 449. So because it's positive, that means that there's 2 real solutions. Okay. And then last one, C, determinant equals b squared minus 4ac. So we're going to have b is, well, before we do this, we need to do a little rearranging, right? Because we have 5t squared plus 5t equals 4t minus 11. So this only works if we get this equal to 0, because it's just from the quadratic equation. And the quadratic equation works whenever we have a quadratic equal to 0. So from here, if we move everything to one side, we have 5t squared plus t plus 11. So that means that a is equal to 5, b equals 1, and c equals 11. So our discriminant is going to equal 1 squared minus 4 times 5 times 11. So this is just going to be equal to, so this will be 1 minus 20 times 11, so negative 219. So because we got a negative, that means that this portion in here is going to be imaginary. So that's why we would say that we have 2 imaginary, or non-real, I guess, is what we can put. 2 non-real solutions. Okay, so for number 20, we have solve 0 equals a naught times t squared plus v naught times t plus s naught for t. So this is a really common like physics equation that you might see. But because we're not told what a naught, v naught, and s naught are, that means that we can't plug anything in and really get an answer for t as just a number. It's just going to be something in terms of those variables, or those constants, sorry. So what we can do then is plug this into the quadratic equation. So t is going to equal, so we'll have negative b, which is v naught, so negative v naught, plus or minus the square root of b squared, so v naught squared, minus 4a, which is a naught, times c, which is s naught, over 2a, so 2a naught. So that's it. And where you might see this in physics, you typically think a naught is like your acceleration, v naught is your like initial velocity, and s naught is like your initial position. So just writing this out over here, we get t equals negative v naught plus or minus square root v naught squared minus 4 a naught s naught over 2a naught. Sorry, I know it's a little messy, but this here, just plugging it into the quadratic equation. Okay, so for number 21, a rectangular piece of carpet covers 200 yards, and the width is 9 yards less than the length. Find the length and the width. Okay, so we have a nice rectangle. So the area is equal to 200 yards squared, and the width is 9 less than the length, so width, length. We know width is equal to L minus 9. And we also know, how can we relate L and W? from area is just area equals L times W. So 200 equals L times W. So now we can take this W here and substitute it right there. So we end up with 200 equals L times L minus 9. So now we solve this, we get L squared minus 9L minus 200 equals 0. So from here, we want to try factoring it, and if we can't, just go ahead and plug it into the quadratic equation. So are we able to think of numbers that multiply to 200 and add to negative 9? I don't really think so, especially because it tells us here that we're going to round to the nearest tenth, so it's probably not going to be nice numbers. So let's just go ahead and use the quadratic equation. So L is going to equal negative b, so 9 plus or minus square root of 9 squared, so 81, minus 4 times 1 times negative 200 over 2a, or just 2. So now let's start plugging this into our calculator. So we're going to have 81 minus 4 times negative 200. So we have this equals 9 plus or minus the square root of 881 over 2. So let's consider the positive and negative versions. So L can either equal 9 over 2 plus square root 881 over 2. So this is one of them, 19.3. So this is the positive version. And this is 19.34. And then the other one, we're going to subtract off the square root 881. So our other length is negative 10.34. So because we're looking at a length, we can't have it be some negative amount, which means that we can just kind of eliminate this one from our possible solutions. So we know our length is 19.34 yards. So now we just need to solve for width. So we know width is 9 less. So width is going to equal 19.3 or minus 9. So that's just going to be 10.34. So now we round to the nearest tenth. So our length equals 19.3. Include your units, yards. And our width is equal to 10.3 yards.
Okay, now looking at question 22. In a classic Seinfeld episode, Jerry tosses a loaf of bread straight upward to his friend George, who is leaning out of a third-story window. The loaf of bread leaves Jerry's hand at a height of 1 meter with an initial velocity of 18 meters per second. Use the model S is equal to negative 1/2 gt squared plus v0t plus s0 to write an equation for the vertical position of the bread, s in meters, t seconds after release. Then use the equation to determine how long it would take to reach George if he catches the bread on the way up at a height of 16 meters, round to the nearest tenth of a second. Okay, so first off, we have our equation of, with an equation of s is equal to negative 1/2 gt squared plus v0t plus s0. So we want our equation in terms of s and t's. So we need to find what g is, what v0 is, and what s0 is, right? Well, v0 is given to us in the equation. That's our initial velocity. So that's going to be 18. We know what our s0 is, and that's the initial height, which we know is 1 meter from the question. And then we need to know what g is, which is gravity. So we're going to use 9.81. Okay, so next we want to plug these values in to create our equation. So s is equal to negative 1/2 times g, 9.81 times t squared plus v naught, 18 t plus s0, so plus 1. So here's first part of our equation, or our question. So now we want to find when our s is equal to 16, right? So we're say 16 is equal to negative 1/2 times 9.81. I'm actually going to do that real quick. So 9.81 times negative 1/2. And that's going to give us negative 4.99 t squared plus 18t plus 1, right? So it kind of looks like a quadratic equation. So I'm going to move this negative 16 over, minus 16. Now we're going to have 0 is equal to negative 4.9 t squared plus 18t, and then minus 15. So next thing we're going to want to do is make our quadratic equation. So negative b plus or minus the square root of b squared minus 4ac all over 2a, right? With this being our a value, this is our b value, this is our c value, right? Just plug it in. So negative 18 plus or minus the square root of 18 squared minus 4 times negative 4.9 times negative 15 all over 2a. So 2 times negative 4.9. Okay, now plugging this into our calculator, we're going to get values of t is equal to 1.3 and 2.4. So t is going to be 1.3 seconds because that occurs first. So he's going to catch it at 1.3 seconds. So next we'll look at question 23. I'm going to solve the polynomial equation 4x cubed minus 6x squared minus 20x plus 30 is equal to 0. So what I'm going to do is I'm going to break this into two separate parts so we can solve for. So 4x cubed minus 6x squared and negative 20x plus 30 is equal to 0. So looking at the 4x cubed minus 6x squared, I want to take out a common factor. So I can see that 2x squared is a common factor. So 2x squared, that's going to leave us with 2x minus 3. Then take out a common factor of negative 20x plus 30. I can see that a common factor is negative 10. So I'm going to take out a negative 10. That's going to leave us with 2x minus 3, right? Is equal to 0. That's going to make our two factors for this equation 2x squared minus 10 and 2x minus 3. So these occur twice. That doesn't mean that we have them twice. It means that's that term occurs. Is equal to 0. So we're going to set each of these equal to 0. So 2x squared minus 10 is equal to 0. And 2x minus 3 is equal to 0. Solving the 2x squared minus 10 equals 0 first, I'm going to add 10 on both sides. So 2x squared is equal to 10. Next, I'm going to divide by 2 on both sides. So x squared is equal to 5. Now we're going to take a square root of both sides. So we're going to have x is equal to plus or minus the square root of 5 since we introduced that square root ourselves. So now we're going to solve the 2x minus 3 is equal to 0. I'm going to add 3 on both sides. So 2x is equal to 3. We're going to divide by 2 on both sides so that x is equal to 3 over 2. So our solutions are 3 over 2, square root of 5, and negative square root of 5. So we want to solve the rational equation of 4d over d minus 5 minus 1 over d plus 1 is equal to 3d squared plus 3 all over d squared minus 4d minus 5. Okay, so my first thought when I say this is I want to add these two fractions together over here, and to do that we want to find the most common denominator, or least common denominator. So it's going to be d minus 5 times d plus 1. So we're going to multiply this one by d plus 1 over d plus 1, and this one by d minus 5 over d minus 5. So that's going to leave us with 4d times d plus 1 over d minus 5 times d plus 1, and then minus d minus 5 over d minus 5 times d plus 1, and is equal to our 3d squared plus 3 over d squared minus 4d minus 5. So we're going to put these two first thing we're going to do is going to distribute that 4d. So we're going to have 4d squared plus 4d all over d minus 5 times d plus 1 minus d minus 5 over d minus 5 times d plus 1. And that's equal to that 3d squared plus 3 over d squared minus 4d minus 5. So now I'm going to combine our numerator. So 4d squared plus 4d minus d minus 5. All that over d minus 5 times d plus 1 and that is equal to 3d squared plus 3 over, I'm going to factor out that d squared minus 4d minus 5, and that gives us d minus 5 times d plus 1. Okay? So now what we're going to do is combine our numerator on the left side. So we're going to have 4d squared plus 3d, then minus minus, so we're going to have a plus 5 there, all over d minus 5 times d plus 1, and it is equal to what we had down up here, squared 3, right? So now we want to solve for d, so what I'm going to do is multiply both sides by d minus 5 times d plus 1. On both sides, it's going to cancel both of them out. So we're going to be left with 4d squared plus 3d plus 5 is equal to 3d squared plus 3. Now I'm going to combine our like terms, and I'm going to do so by subtracting 3d squared and minus 3 on this side to our left side. So minus 3d squared minus 3. So we're left with d squared plus 3d plus 2 is equal to 0. So now we want to factor this and find what d is. So it factors down to d plus 1 and d plus 2 is equal to 0. So our two values for d are -1 and -2. But now we need to check to make sure this works in our equation. So go back to our original equation of 4d over d minus 5 minus 1 over d plus 1 is equal to 3d squared plus 3 over d squared minus 4d minus 5. So I'm going to plug in -1. So we're going to have 4 times -1 over -1 minus 5 minus 1 over -1 plus 1 is equal to 3 times -1 squared plus 3 over negative 1 squared minus 4 times negative 1 minus 5. So we can see that right here we're going to have a 1 over negative 1 plus 1. So we're going to have a 1 over 0. So we know that negative 1 cannot be one of our factors. So I'm going to go back through, and I'm going to plug in negative 2. Negative 2, negative 2, 2 minus 5, negative 2 squared, negative 2, negative 2. And when I plug this into my calculator, we get 15 over 7 is equal to 15 over 7. So we know that D is going to equal negative 2. So we know that D is negative 2. So next we're going to look at 25a. So 2 times the square root of 3m plus 4 minus 3 is equal to 5. And we want to solve for m. So we want to get everything together. So I'm going to add the 3 there. So we're going to have 2 times the square root of 3m plus 4 is equal to 8. Next thing we want to do is divide both sides by 2. So we're going to have the square root of 3m plus 4 is equal to 4. So we want to get rid of the square root now. So we're going to square both sides. So 3m plus 4 is equal to 4 squared, which is 16. So now we want to get m by itself. So we're going to subtract 4 on both sides. So 3m is equal to 12. Now we're going to divide both sides by 3 to solve for m. So now we know that m is equal to 4. And next we're going to go back in and check to see if that actually works. So we're going to do 2 times 3 times 4 plus 4 minus 3 is equal to 5. So we get the left side is equal to 5 when we plug it into the calculator, and the right side is 5. So m can equal 4. So we're going to have a solution of 4. All right, next we're going to solve for 25b. So the square root of 51 minus 14x. Then outside the radical, we have a plus 4, and that is equal to x minus 2. I'm just going to do a quick fix of that 4 real quick. Okay. So I'm going to subtract this 4 on both sides. So we're going to have the square root of 51 minus 14x is equal to x minus 6. So next we want to square both sides to get rid of that radical. So 51 minus 14x is equal to x minus 6 squared. So we want to FOIL out that x minus 6. So x minus 6 times x minus 6. So x times x squared, negative 6 times x minus 6, x times negative 6, minus 6x again, negative 6 times negative 6. So we're going to have plus 36 here. So now we have 51 minus 14x is equal to x squared minus 12x plus 36. So we want to subtract 51 on both sides and add 14x on both sides. So now we're left with 0 is equal to x squared plus 2x and then minus 15. So now we need to think about the two factors that give us this. So we're going to have x plus 5 and x minus 3. So that means our two values of x are going to be x is equal to negative 5 and 3. Now we need to check this with our equation to make sure that these are actually valid answers for x. So we're going to do square root of 51 minus 14 times negative 5 plus 4 is equal to negative 5 minus 2. So if we put that into our calculator, 51 minus 14 times negative 5 plus 4. One side leaves us with 15. That's going to equal negative 7, which is not true, right? So we know negative 5 cannot be one of our solutions. So now I'm going to try with positive 3. So 51 minus 14 times 3 plus 4 is equal to 3 minus 2. So on that side, now we're left with square root of 51 minus 14 times 3 plus 4, which leaves us with 7, and that's going to be equal to 1, which is not true. So we have no solutions here, so we can write that as squiggly bracket, empty squiggly bracket. So now looking at question 25C, we have the square root of x minus 2 is equal to the square root of 2x plus 3 minus 2. So first thing we want to do on this case is square both sides. So the square of the left side is going to leave us with x minus 2 is equal to the square root of 2x plus 3 minus 2 times the square root of 2x plus 3 minus 2. I'm just going to bring our left side down, so x minus 2. So now we're going to FOIL our right side. So square root of 2x plus 3 times square root of 2x plus 3 is going to leave us with 2x plus 3. And then minus 2 times 2x plus 3 square root. So minus 2 times the square root of 2x plus 3 minus 2 times square root of 2x plus 3. And then negative 2 times negative 2 is plus 4. I'm going to simplify our right side. So x minus 2 is equal to 2x plus 7 minus 4 times the square root of 2x plus 3, right? So I'm now going to move our minus 2x and our minus 7 over, so minus 2x minus 7. So that's going to leave us with negative x minus 9 is equal to negative 4 times the square root of 2x plus 3. I'm now going to square both sides again. So we're going to have minus x minus 9 times minus x minus 9 is equal to 16 times 2x plus 3. So on our left side, I'm going to FOIL out. So x squared plus 9x plus 9x plus 81 is going to leave us with 32x. I'm also going to distribute that 16 on the right side. So 32x plus 48. So now I'm going to write this as x squared plus 18x plus 81 is equal to 32x plus 48. I'm going to subtract the 32x and the 48 on both sides. So minus 32x minus 48. So we're going to be left with x squared and then minus 14x plus 33 is equal to 0. So we want to think about what two numbers multiply to give us 33 and add up to give us negative 14. So it's going to be x minus 11 and x minus 3 is equal to 0. So we know that x is going to be 3 and x is going to be 11, right? But now what we want to do is check to make sure those are valid solutions. So I'm going to go back to the beginning here. I'm going to erase all this, if it'll let me for some reason. So we said x was equal to 3 and x was equal to 11. So we're going to plug that back in. So we're going to have the square root of 3 minus 2 is equal to the square root of 2 times 3 plus 3 minus 2. If we plug that into our calculator, we're going to have 1 on our left side, and then we're also on our right side, we're going to have 1 on our right side as well. So that's good. So x can equal 3. So now let's try 11. So the square root of 11 minus 2 is equal to the square root of 2 times 11 plus 3 and minus 2. So our left side is going to give us 3. Our right side is also going to give us 3. So note that's a valid solution. So x can also equal 11. So we're going to write this as squiggly bracket 3 and 11 squiggly bracket. So now we want to look at number 26. We want to solve for 3 times x minus 6 times the power of 2/3 is equal to 48. First thing I see is I'm going to divide by 3 on both sides. So 48 divided by 3 leaves us with 16. So x minus 6 to the 2/3 is equal to 16. So we want to do the inverse of 2/3. So we're going to do the 3/2, then to 3/2. So we're going to have x minus 6 on this side. Then we're going to have 16 to 3/2, which is going to leave us 16 to the power of 3/2, which you could also write this as 16 to the 3rd to the 1/2, which is going to leave us with 64. 64. Now we're going to add 6 on both sides. I'm sorry, plus or minus 64. So we add 6 to, so 64 plus 6, and x is equal to negative 64 plus 6. So our x's are going to be 70 and then negative 58. So now we're going to have to go back through and check that. So we're going to have 3 times 70 minus 6 to the 2/3 is equal to 48. And then 3 times negative 58 minus 6 to the 2/3 is equal to 48. So for both of them, we get 48 is equal to 48. 48 is equal to 48. So we know that x can be 70 and negative 58. So we're going to write that. I'm going to come up here, squiggly bracket. The squiggly bracket of 70. Sorry, we want to write our negative number first. We're going to have negative 58 and 70.
Number 27A, making an appropriate substitution to solve the following quadratic-like equations. In parentheses, 3x plus 7 squared minus 6, 3x plus 7 minus 16 is equal to 0. So with this, we can see that this is the same, and that it looks like a quadratic that we have already been solving. So we'll let u equal 3x plus 7. When we substitute that in, we get that we get u squared minus 6u minus 16 is equal to 0. Now you can use factoring, quadratic equation, or completing the square. We can see, if you can see it, we can see that this will be u minus 8u plus 2 equals 0 through factoring, but you can also use the other methods, and you'll get that u is equal to positive 8 and a negative 2. Now we can set these equal to what we said u was, so we'll do the 8 first. subtract off the 7 from both sides, and then we'll divide by 3. And then we'll do the same thing for our negative 2. Again, subtract off 7 from both sides, and then divide by 3. So, x is equal to a positive 1/3 and a negative 3. All right, now for b, y to the 1/2 minus y to the 1/4 minus 6 equals 0. And again, it asks us to make the substitution in the quadratic-like equations. So we should be able to identify, we go, oh, that's y to the 1/4, and if we square that, we'll get y to the 1/2. So we might say that x is equal to y to the 1/4. Now when we make that substitution, we get x squared minus x minus 6 equals 0. And again, just like the last one, you can use any of the 3 methods mentioned. We will use factoring for this case. But either way, we should get that x is equal to 3 and negative 2. And then we set that equal to our y equation that we started. So 3 is equal to y to the 1/4. We'll raise both sides to the 4th, and we'll get 81 is equal to y. Then we can do the same thing for the negative 2. Negative 2 is equal to y to the 1/4. Raise both sides to the 4th, and we'll get 16 is equal to y. Now, because we did some substitution, we need to check to make sure that everything works out. So 81 to the 1/2 minus 81 to the 1/4 minus 6, we need to make sure that that equals 0. So this will be 9 minus 3 minus 6 equals 0, and we get that 0 equals 0. Good. Now if we do when it equals 16, we get 16 to the 1/2 minus 16 to the 1/4 minus 6 equals 0. And we'll get 4 minus 2 minus 6 equals 0. And we'll end up with negative 4 equaling 0. So we need to reject this y equals 16, leaving us with y equals 81.